Today's topic I've taken as multi-domain system modeling for electric vehicle. So before going into the actual presentation, I just want to talk about how today's products are. Today's products are increasingly becoming complex and complex as well as this system of system connected. The entire transition of technology is moving towards e-mobility in terms of the systems like we are into safer, lighter, greener, and smarter vehicles. So if you look into the tools, methods, and process that need to be continuous, multi-domain, multidisciplinary, and then openness to use. So the reason I've just put this is like today you can't say that okay, I'll only work on one particular subsystem like motors or a control system or inverter or a battery. Today we are forced to know about how the interdiscipline models works together and how overall a product in terms of product development cycle you need to understand the different physics and math, how overall different subsystem interacts, and in terms of coding or implementation. So you need to aware about all the other disciplines as well. You can't restrict to yourself to one particular domain. So that's the reason for this. How we helpful in terms of model based development. So Altair also has a suite of model based design suite of solutions. So if you look into the V curve, as you most of you know about this V curve in terms of product development cycle, it goes from requirement phase, concept phase, detail phase, and then the procurement building or detailed design and simulation. And the right hand side what we talk about is the individual component testing, system integration and verification and validation of your products. So irrespective of any product development, you be it aircraft, automotive, heavy engineering, or consumer product lines, appliances, whatsoever. But today's our people are forced to know for people are more working towards on the model based design side. So if you look into the week of today's product, not only purely it's a combination of mechanical, it's a combination of electrical, electronics, control systems, software, and then if you look into the product development cycle, as I said, so it's a combination of entire thing. Like typically, if you look into Alta suite of product lines, we were more strong in terms of 3D modeling, in terms of multi physics. So that's our strength. Going forward, like if we took into 3D, my colleague would have spoke about flux for electromagnetic. That is for designing your motors, sensors, or actuators, or transformers for on the multi physics side and thermal aspects of it. Not only on the and even on the structural side we have manufacturing and then the electron and even the multi-body dynamics and then CFD as well, computational fluid dynamics. This is our strength. And then I'm going to talk about today only on system modeling. When I talk about system modeling, where on the left hand side you will be knowing about the terminologies like software in loop, processor in loop. On the right hand side what you will talk is the hardware in loop simulation. So on the right hand side is basically about the real-time simulation. So today I will show you a live demo in spinning up your motor, spinning up a PMSM motor with the inverter board and the controller board, how you can develop the control algorithm and generate the code and deploy and then test it. That will be the main focus in terms of last. I will try to conclude that. And if you look at here on the concept phase, we have equation-based modeling, main system simulation of integrating different disciplines into it. Okay, this is about the week of in terms of product development cycle. I'm just trying to connect product development in terms of using our portfolio of products into these different stages of your cycles. So as you say, if you take an electric car or two-wheeler consumer appliance, like consumable, like in terms of two-wheeler, three-wheeler, four-wheeler, or passenger vehicles. So if you look into the different subsystems of electric mobility, it has the mainly today I will focus on system modeling and controls, power electronics and inverters design, and then real-time controller implementation on the hardware target. So that is on the covering my entire presentation. Spoke about traction motor design, designing any type of motor, maybe a PLDC motor, PMS to use it. You can design the motor from a scratch. And then even the battery management system I will touch upon. And then apart from that, mechanically you have other systems integrating it as dynamics, vehicle dynamics, suspension modelings, or communication, electromagnetics in terms of antenna design, or in terms of NVH. These are the other areas where other domain people can work. When you overall integrate, it's a combination of electrical engineering, mechanical, computer science, and then combination even electronic communication all put together. And everyone's contribution will be different in perspective to different domains. So you can have all these lightweighting, crash safety, vibrations, and powertrain modeling, ride handling, and efficiency, and so on. So that's the broader view of. So what we are different and what we are unique is in terms of different fidelity of models. So if you look into it, like I've taken three typical example. One is suspension for mechatronic example, and another one is an electric motor, and then the electronic circuits. So am I audible? So
Yes, yes.
any? Yes, yes. So please feel, because in case I'll be talking, if because you we will all will be muted. In case if I lost, so you can probably remind me like where I've lost. So
Yes,
any
sure.
questions also feel free. Let us have an interactive session.